What's up, everybody? In this video, we're going to look at time and how to synchronize time on the Arduino. On its own, the Arduino does not understand time. It does not know what time it is at any given point. For this reason, if we want to have elements synchronized at specific times, we need the Arduino to track the time. We will do this by making a request to a network time protocol, also known as an NTP server. An NTP server is a piece of internet infrastructure that helps computers and network devices maintain accurate time synchronization. Think of it as a highly precise digital clock that other devices can check to ensure they're showing the correct time. We'll use an example piece of code to do this. Open the Arduino IDE and click File, Examples, RTC, RTC_NTP sync. If you look at the sketch that opens, it says the sketch will set the real-time clock, or RTC, on the Arduino Uno R4 Wi-Fi. There is an RTC chip on the Arduino. When you synchronize this chip, it can keep track of time. In order to do this, you'll need to provide a small power source between 1.6 volts and 3.6 volts to the VRTC pin. This will ensure that when you disconnect your Arduino, it still keeps track of time. Additionally, there are instructions that we need to download the NTP client library. Click on the Library Manager tab and search for NTP client and install the library. Once the library is installed, click on the Arduino Secrets tab and enter your Wi-Fi credentials. Next, click on the RTC_NTP sync tab. Click Upload and open the serial monitor. If successful, you should see the Arduino connect to your Wi-Fi and set the time. It gets something called Unix time, and the time we get is ahead of the time in my location. Let's debug this. Open a browser and open an AI. Prompt the AI with, "What is Unix time?" The response tells us about Unix time and the epoch. If you want, you can ask some more questions to learn more about Unix time. If you look at the initial response and the Arduino sketch, you will see a reference to UTC. Let's find out what this is. Reply with, "What is UTC?" You will see that there is an offset of -5 for New York. This is the same time zone that I am in. Go back to the sketch and look for the time zone offset hours variable. Change this to -5 or whichever offset matches your location. Upload the sketch, and you should see that the Arduino is downloading the correct time. Cool! We just synchronized the Arduino with an NTP server and have the time at our location. As long as we power the Arduino, it will keep track of time. As mentioned previously, if we apply a power source between 1.6 volts and 3.6 volts to the VRTC pin, the RTC chip will continue to function even if the main power source is cut. This is how a lot of modern-day electronics keep track of time. They have a separate power source, normally like a coin cell battery, that powers an RTC chip. So now what? Let's send our code to an AI and ask it to trigger some events based on different times of the day. This is a sketch that we will create and leave to see how well it keeps track of time. Copy the code from the existing sketch. Start a new chat with an AI. Add a prompt of, "Update the following code. At the start of each hour and every quarter hour, print the time to the serial monitor. At 9 a.m., print the message, 'Good morning.' At 12 p.m., print, 'Good afternoon.' At 6 p.m., print, 'Good evening.' The time zone should be EST. Paste the code below the prompt. Copy the generated code and upload it to the Arduino. There's a small error, but the Arduino is suggesting a solution. Change get hours to get hour and try uploading. Let the sketch sit for a while. Sweet. We now have a sketch that triggers events based on the time of day. At the end of this video, you should be able to get the time from an NTP server, update the RTC on the Arduino, and synchronize timed events.